Is that the diagram drawn doesn't really fit. Well, I guess it does really on 35. We have one function on top and one function on bottom.
Can we expect 33 on the
33?
No.
Oh, because they only give you that one where you have to switch things around. Maybe if I made that extra credit. That'd be kind of a nice extra credit, right? It's a problem you would have really expected, and all you have to keep in mind is switch X and Y. So that'd be fun to get for extra credit. But other than that, no, it wouldn't be on the main body of the test. It's not fair. So what am I doing here, number 5? Why are they giving us rho? Oh, we need rho in order to calculate the moments. When you're doing the centroid, you don't, because the rho that's a factor of the numerator here, I mean, really, there's a factor of rho. That's the Greek letter rho in each of those, so they cancel out. But if you're just being asked for the numerator, which is the moment, well, then you need to throw that constant back in there. So 35. They don't tell us what that curve is. I know they want us to assume it's a circle. Why the hell should I make my life difficult just because they want me to assume what they want me to assume? The only thing is, what other curve would I pick? I could say now, I think a good answer might be, the author has not identified the curve which we're supposed to integrate, therefore this problem has no solution. So that would be my answer if that was what I gave you on a test. If somebody gave me that on test, I'd say, hey, buddy, tell me what this curve is. I'm not going to assume that's a circle. Why make my life difficult? Make your life difficult. And then I'd, bitch and moan when they gave me a 0 on it. So I think that's supposed to be a circle centered at the origin of radius 4. So pretend that's a circle, which is going to take some pretend. Oh well. Anyway, pretend it's a circle centered at the origin with radius 4. Now, we don't really want that circle, but we do want that circle's equation, no doubt. The equation of that circle is x squared plus y squared equals 16. Now, what they've done is they have taken the circle in the first quadrant only, and they've sort of attached a rectangle from x equals 4 to x equals 0, and the width is 2. So where the circle would have stopped right there, it quits being circular, and it goes down straight and comes over straight. So a rectangle and a quarter of a circle above it. So what is the equation of the curve on top? Y equals square root. There you go. We don't need the minus because it's in the first quadrant. What is the equation of the curve on bottom? And then we have our two equations. Right? The area is going to be the integral from from 0 to 4. The curve on top minus the curve on bottom. Oh no. Rats. Shall we look that integral up in the table of integrals, or shall we actually do it? So you want a little bit of practice, I see that. So what shall we substitute here? X equal 4 sine? Okay, I just want to see if I can shake you. Couldn't shake it. So dx. 4 cos theta d theta. All right, so I guess that's all we really need there. This is going to turn into, therefore, the integral from 0 to pi over 2. Gosh, gosh, think of what a nice integral this would have been if we were using polar coordinates, huh? You might want to start thinking about polar coordinates. And even if you don't, just wait an hour or so, and I'll force you to. But yeah, see, 0 to pi over 2. If you think about it like that, you didn't even need to figure out the limits of integration. And clearly 0 to pi over 2. Don't worry, you'll think that way very shortly. Wait till we do something like, guys, remember how to draw those roses?
Oh, yeah.
Oh,
Isn't that
God.
fun? Huh? And you guys remember like those, say those butt functions?
Yeah.
I'll let this one even has hemorrhoid. So what if they add, well, let's assume it doesn't. So what if I asked you to find the area inside the petals, but outside the butt function? Well, which is what I'll do on the next exam. You'll find one of those and then multiply by 4. And it'll be all kinds of fun R's and thetas and yeah, just trying to light a fire under you this weekend. You'll really want to review polar coordinates. Okay, so let's finish this problem. We're going to write this now as 2 integrals. We're going to do our substitution for the radical. So that's 0 to pi over 2. And this is the square root of 16 minus 16 sine squared. Sure. And then the dx we're going to replace with 4 cosine theta d theta. And we're going to add to that the integral from 0 to 4 of 2 dx. I mean, we could have just added the area of the rectangle, but I'm trying to show you something that we're going to have to use on the next formula that we do. Right? But that is a way of finding the area of the rectangle, which you guys all know what it is, right? Well, it's called length times width.
Yeah.
8 in this case. This will be 8. That will be 8, right? And now here we're going to factor out this 4. You think it's going to make a 16, but remember we're going to get a cosine squared, so that 1/2 is going to come out and turn that 16 into an 8. And that will be 1 plus, remember the formula for cosine squared, 1 plus cosine 2 theta.
Where does the half come out from?
Pardon me?
Where does the half come out from?
Yes. Right, that half. Is that? Yeah, and that half is not under the radical or anything like that. And now here we're going to get 2x. Evaluated from 0 to 4. That's where the 8 comes from. So here we're ready to integrate. So a plus 4 sine 2 theta, and that's evaluate 8 theta, sorry about that, 8 theta plus 4 sine 2 theta from 0 to 2 pi, pi over 2. We already know that's an 8, plus 8. So what do I get there? 4 pi, that'll be a 0. When I plug in zeros, everything's 0, so 4 pi plus 8. And now when we do x bar, we are going to divide by 4 pi plus 8. The numerator is going to be the integral from 0 to 4. And right, I did not need to really attach the 2 this way because I could have found the area just by finding the area of a rectangle. But notice in this formula, now it's necessary, isn't it? I've got to have x times the function on top, square root 16 minus x squared, minus the function on bottom, which is a minus 2. So now it's important because it turns into a 2x, not a constant 2. Correct? So this is 1 over 4 pi plus 8. And tell me about these integrals. X square root 16 minus x squared dx on 0 to 4. And the integral of 2x dx also on 0 to 4. Second integral is pretty easy. What about that first integral, though, right? Trig substitution?
Hey, you can use
Well, not only yes, but hell yes. A lot of you were on these tests taking what were supposed to be straightforward substitutions and writing pages and pages of substitution after substitution were all completely correct, but just sort of taking you around in big circles and big circles. So, if you don't get the right substitution, you may be writing correct things, it may just not be taking you anywhere. So here, Monty's right, it's Calc 1, that's Calc 1 integral, isn't it? Yeah. U equals 16 minus x squared, x dx is basically du there. So I'm going to assume you can finish this. When we do y bar, we're going to have 1 over 4 pi plus 8, integral 0 to 4, 1/2, and we're going to take the square root of 16 minus x squared and square it, minus the minus 2 and square it. And so that one I can assume you will be able to do, because that's even easier, isn't it? Calc 1 integration once again. Question? Comment?
Isn't like what is the first line, just the first quadrant, and then y was -2, just the line, but what about that little, like, thing connecting the two lines? Does that make sense?
You mean the side here at 4?
Yeah,
Well, that's just the edge of the...
so
Plate.
you don't have to like,
No, because that's straight, right? It comes right down from there. Now, if it was at an angle or something like that, we'd be all messed up. But it's not. They deliberately did that to keep it doable. So what do you say we take that break? Let's take a little bit of a long break so I can try to finish grading these ugly monsters.